Hey y'all, I'm focusing today on the handout that I gave to you today in class. It's page 21. It's going to act like the very last page of your packet for Unit 3. So just kind of add that on. We are focusing on finding the angle using inverses. Now that's not going to happen until the second half of this video. But the first half I do want to kind of go over how to use the calculator again for you, the TI Nspire to be more specific. If you have one at home, great. If not, that's okay. We've done some practice in class. And if you ever need more help, then just please let me know, and I'll show you a quick hint or two, whatever you need. Also, I do want to go over some identities and how to prove these identities, just like we did in a previous video. So to begin with the first section with the calculator, the TI Nspire, remember, by default, speaks in terms of radians. So if you take a look at the first 4 examples, those are all angles that are in degree mode. So what we're going to have to do in the TI Nspire is we're going to have to actually change the angle that's given to you in degree form so the calculator understands what you want. So the first thing it's asking for is cos of 125 degrees. So on the TI Nspire, remember there is a trig button for that. So I'm going to go over and I'm going to scroll over to cosine, type in 125, and now for it to understand that I want 125 degrees, not radians, I'm going to have to go down to where I have the pi button. It's right next to H. So hit pi, and if you look on your screen right under pi, there is the degree symbol. So just hit enter on that, and now all of a sudden you're in degree form, or degree mode. Hit enter on that, and there's your answer. Negative 0.5736. And the instructions, by the way, do tell you to round to 4 decimal places, so just be mindful you're doing that. Okay, I'm going to skip to number 3. Number 3 is asking for cotangent of negative 150 degrees. Now on the TI Nspire, there is an actual selection and an actual button for that, so if you go to trig, there is something that you can, there is a cotangent selection. So go ahead and hit that, hit negative 150, again don't forget the degree symbol, and hit enter, and you should get 1.7321. Now at home, if you do not have a TI Nspire, that's okay. If you have a TI 83 or an 84, here's what you'll have to do, because on those calculators you don't have all 6 trig functions. You only have sine, cosine, and tangent, or you only have buttons for those. And so what you're going to have to do on the TI 83 or 84 is you're going to have to actually think about the reciprocal identities. So remember, cotangent is a reciprocal of tangent. So you'll actually have to tell your calculator that. So let me demonstrate on here. It's very similar. So you'll hit 1 divided by tangent of negative 150 degrees. And if you tell that to your calculator, and again, it understands that you want cotangent. Okay, so there's that. Number 5, it's asking for secant of 3 pi over 5. Now, notice this is already in radian form, and remember the Nspire understands radian form by default. So I'm going to go into my Nspire and hit trig. I want to go over to secant, and I want 3 pi over 5, hit enter, oops, there we go, hit enter, and I have negative 3.2361. Now again, if you have a TI 83 or an 84 that you're using right now, you want to actually think of what is the reciprocal of secant. So remember, secant is a reciprocal of cosine, so I'm going to have to use 1 over cos of the same angle, 3 pi over 5. And hit enter. And there you go, same answer. Just be mindful, you want the reciprocal of the function, not the reciprocal of the angle, because that's going to give you something completely different. You want the angle to be untouched. It's just the function that you're taking the reciprocal of, if you need to. Just also take a mental note that in class you will be required to use an Nspire. So if you have any questions regarding how to use it and actually working with it, just come see me and I'll make sure that we can straighten those things out. Okay, number 8 is asking for sine of 3.42. So I'm going to go to sine 3.42, and also that's in radian form, and remember the calculator understands that, so just hit enter. And there you go, negative 0.2748. What I want you to do is, at this point, notice I've only done 4, there's 4 remaining. What I want you to do is try these 4 and pause the video, and as your answers, this is what you should get. Okay? And you can find these answers later also online under my notes section. Okay? Now, back to the handout. So number 9 and 10, numbers 9 and 10, it's asking for you to verify using trig identity. So remember, you want to try and write this down actually. You want to try and write the left side in terms of sine and cosine. And the reason why we do that is because sine and cosine are the easiest trig functions that we have that we can actually work with. So I'm going to rewrite on number 9 everything on the left side of the equal sign in terms of sine and cosine. So as we remember, tangent is sine over cos. So let me write that down. Sine of x over cos of x. And then I know cotangent is a reciprocal of that, so that should be cos of x over sine of x. And we want to prove that it equals the right side. So now let's see what happens here. If I take a look at that, I'm multiplying these two fractions, and I do have cos that are diagonal to each other, and I have sine that's diagonal to each other, and all of a sudden, I have nothing left. Just be careful, guys. Even though everything is gone, really what's left is a simple 1, which does equal the 1 from the right side, and there you go, done. Number 10, same idea. You want to rewrite the entire left side in terms of sine and cosine. The first part is already done for me. It's already in sine. Cotangent, though, I know is cos of x over sine of x. And I want to show that it equals cos. So what I'm going to do is I'm going to write this first sine of x that's given over, put it over 1, so that once I multiply and simplify, I know that the signs cancel, leaving me with cos of x, which is equal to the right side, which is cos of x. There you go. Really make sure you know those identities. Okay, now here we go. Using identities, what we're going to do on this last section, or the second half, is find 2 solutions for the given equations. Now, we've done a couple of these on a previous video, but I do want to go back over that. Now, what's really important is to understand what's being asked. Notice that here you're given a cos value, but you don't know the angle. So really, the way you would read this, again, is for what angle, or angles, is your cos value square root of 3 over 2. So the first thing you want to do is actually write this that way. For what angle is your cos value root 3 over 2? And the only reason I have that inverse notation is because I've moved it from the left side onto the right side. That way it shows me that I want the angle at which cos, my x value, is root 3 over 2. So now, what I want to notice is that is a positive, it's a positive cos value. So now I have to think, okay, where is cos a positive value? Where is cos a positive value? And cos is positive on the entire right side of a unit circle, so quadrants 1 and 4. So I should have an answer, because it does say find 2 solutions. I should have an answer from the first and one from the 4th quadrant. And if you think about that, pause this video if you need to. But you should find that to be true at pi over 6 and 11 pi over 6. That's it. Number 2, Now I want for what angle, and I'm going to rewrite this, for what angle is your sine value negative square root of 3 over 2? For what angle, or what angles? So again, I want to notice that I'm being asked about a negative sine value. Now remember, sine is your y value, and y is negative everything below the x-axis. So we're looking at quadrants 3 and 4. So in quadrant 3, that angle would be 4 pi over 3. And in quadrant 4, that angle would be at 5 pi over 3. Number 3, it's asking about cosecant. Now, here's the thing. Whenever you're dealing with cosecant, secant, or cotangent, always try to refer those things back to sine and cosine, because again, everything is simpler when you refer it back to sine and cosine. So I'm going to actually rewrite this. Cosecant I know is a reciprocal of sine. So really what I'm being told is that sine of theta is the reciprocal of that, so negative a half. Now it's all of a sudden it's a lot easier to work with. So again, for what angle is sine negative a half? So again, notice that we're being asked about a negative sine value, which are, or your sine value is negative in quadrants 3 and 4, just like we said. And that value specifically for sine is at 7 pi over 6 and 11 pi over 6. Number 4 is being asked about cotangent. Now I'm going to refer back, I'm going to call that tangent. So tangent of theta equals 1 over square root of 3. Now I know that I can find tangent by using sine over cos. So now we did this in a previous video. Again, you do have to think back, okay, what can I do? What combination of fractions can I have, sine over cos, so that I end up with this simplified version? So now that has to be, pause the video again if you need to, but it should be a half comma square root of 3 over 2. And so I know that I'm really looking for sine to be a half and cos to be square root of 3 over 2. So a couple of things on that. I'm looking for, because notice this is a positive value, I need to look for two things. Where are sine and cos both positive, and where are they both negative? Because those are the only two places where you'll actually end up with a positive tan and a positive cotan. So I know that everything is positive in quadrant 1, and I know everything is negative in quadrant 3. So my answer that comes out from quadrant 1 is pi over 6, and from quadrant 3, 7 pi over 6. Okay, numbers 5 and 6 are the actual equations that we're going to solve. Now this is a little bit extra work, but it is very doable, and it turns into some examples that we've already done. So, and I'll tell you which ones. What we're going to do is we're going to actually treat this like an equation where what we're looking for is right here. We're trying to get sine of x by itself. On number 6, we'll try to get cos of x by itself. So think of this very simply. If you were to kind of ignore that, just call that some unknown, we're going to go ahead and on number 5, subtract the 1. So you have 2 sine of x equals negative 1. Now again, I want sine of x by itself, so I'm going to go ahead and divide both sides by 2 so that this goes away. And now I have sine of x equals negative a half. So now notice it turns into one of these problems that are above. Of course, instead of theta, you have x, but it's still the same idea. So now I want, for what angle is sine negative a half? And you may remember seeing this. This is actually the same now. It's turned into the same thing as number 3 from above. And so your answer is 7 pi over 6, and 11 pi over 6. There you go. Number 6, again, we are looking for cos of x. I want that by itself, so I'm going to go ahead and subtract square root of 3 from both sides. And so I have negative 2 cos of x equals negative square root of 3. And again, I want cos of x by itself, so I'm going to divide both sides by negative 2 to get that out of there. And so I have cos of x equals negative divided by negative is positive square root of 3 over 2. So now again, I want for what angle is cos square root of 3 over 2. And again, that should be very, very familiar. That actually turned into number 1 from up above, and that answer we had was pi over 6 and 11 pi over 6. And there you go, finding the angle using inverses. Bye, y'all.